Good morning, everyone, again, and welcome to APAN conference.
Morning.
So we are about to start our technical sessions. So we have three tracks: network and AI, and then computer vision. So we start with the networking track, and we have our session chairs here. Dr. Yasing C and then Professor Mercury. So they will be handling the sessions today. And for the presentations, we have 10 minutes allocated for the presentation and 5 minutes for the Q&A. So over to you. Thank you.
Yeah, welcome to the session 1, the networking and HPC. And let's welcome the first talk, which is about the design development of a low-cost modular swarm robotic platform. And let's welcome the speaker, Cesara, to give his talk.
Good morning, all of you.
Hi everyone, I am Cesara De Silva from the Department of Mechanical Engineering, Faculty of Engineering, University of Sri Lanka. It's a pleasure to present our research project titled Design and Development a Low-Cost Modular Sound Robotic Platform at Asia Pacific Advanced Network 3rd International Conference. Dilshan Pera, Virupiti, and Dr. Darshana Markit are the other co-authors of this research project. So first of all, I will go through the presentation outline. In here, I will go through the research initiation first, then the research methodology, then I will present key findings of this research project. Finally, I will conclude the research. So when we come to the research initiation part, the swarm means the group, what we can achieve and what we can't achieve by a single one. And modularity means we can convert a system to another system by adding or removing subparts. So that's the meaning of simply modularity. Then in here we combine modularity and swarm concepts together. So when you come to the motivation behind our research, this is a very growing field. So we want to give some accessible area to this area, this swarm concepts. So make swarm robotics technology accessible to a wide audience and further advance the field, drive innovation and growth in the field of swarm robotics, meet the growing demand for low-cost and accessible robotics technology. So these are some literature-related works. So this is a MarkSport modular and vision-enabled platform, and this is a MONA platform here. MONA platform and Arduino-based open hardware, and this is a SMORAS self-assembling reconfigurable unit, and this is a summary of a commonly available sound robotics platform, and this price is based for 1 unit of this platform. You can see the high cost of this platform. And finally, the aim and the specific objective of this research. Main aim is to propose and validate a scalable low-cost modular sound robotic platform with specific objectives to propose and evaluate a modular robotic platform in both physical and algorithm ways. And we are proposing a PCB to our modular sound robotic platform, and finally to develop a simulation environment for testing and analyzing swarm behavior. So simply the roadmap of our research: first, literature review and problem identification, then we design of modular robot architecture, then PCB, hardware integration, simulation platform setup, and finally prototype implementation and validation code. So now we can move to the methodology section. So we are targeting to build a good project through this research. Therefore, targeting of that, we design our physical base according to the self-assembling concepts. So in algorithm-based, HTML-based user interface to select algorithms and configure roles easily. All the algorithms and web servers are uploaded to the GitHub and share with users. Robot position and position control algorithms were tested in prototyping, and also in this phase we are using Arupa marker system for the localization. We are working to get here to improve this one with common camera and systems, but in here we use Arcomarker system. And this is the main dual layered architecture what we proposed in here. So there is a primary layer and secondary layer role. So the primary layer is used to connect main sensors and our main microcontroller part. Secondary layer is to attach external things and wider area, and it means multiplexer. So here in PCB designing part, this is a very important for our power management. So we implemented two separate 5-volt regulators, one for microcontroller unit and another dedicated for sensors and multiplexers. So these are the 4 sensors and modules in our single robot: sharp piston sensors, line following sensors, obstacle avoidance sensors, and a wireless module for inter-robot communication, centralized and decentralized communications, analog multiplexer for managing multiple sensor inputs. And this is for our secondary layers, to connect external more sensors and hardware to the robot, because this is a modular concept. So supports multiple voltage lines, 12, 5, and 3.3, dedicated voltage regulations for sensor and peripheral devices, and also in here communication interface support, SPI interface support up to 2 devices, and I2C interface support up to 5 peripheral devices, enabling modular sensor expansion board integration. So on simulation platform, we selected Copiliasim because it supports language like Lua and Python, and we design our robots in SolidWorks and import to the Copiliasim. Simulation goals included data following and formation control in this phase. So GPS tracking system and virtual targets enable behavior control using Lua scripting and proximity calculations. Also swarm behavior was tested here. We tested the system using 3 robots physically and mainly 3 robots using simulation environment. You can see those things in results and discussion section. So we can move to the results section. So this is the physical arena what we use to test and validate our system. Okay, so you can see 3 robots in this system, and obstacle in here, and this is the real-time localization monitoring system with physical robots. And here, this is the HTML interface. We can select robot ID in here, and we can select pattern formation, very user-friendly interface. And this is the final primary and secondary layer PCBs. We tested and we validated our system. You can see here, primary layer, our microcontroller unit. And finally, this very important results in quantitative analysis achieved average positional level to 5 centimeter using Arcomarkers. There are some limitation in Arcomarkers because the visibility and robot orientation. So we are now working to improve these things in our next phases. Measured average delay 150 milliseconds, enable smooth coordination among robots. So after charge, we can nearly 20 minutes of continuous operation by one robot. Battery performance, so in robustness, on coordination remains stable despite temporary communication losses up to 2 seconds, and this system is open source access. And these are some examples from behavior simulation platform. So this is pattern formation. So here we some set of swarms, some set of robots as a swarm. So we can select whatever the pattern what we want to achieve. Then finally, the pattern formation happened. So this is in Copiliasim software. Okay, so, and now we can move some. This is a swarm task using 3 robots. So you can see here, task achieved by 3 robots in a swarm. Okay. So we validate our system through simulation platform also. Okay, so when we come to the cost analysis, overall we spend 48,000 for 3 robots. So therefore, altogether $161 for 3 robots and 54, already $54 for one robot. So this can be decreasing when we are increasing the number of robots. And this price is also including all the key components, even all sensors, PCB, chassis, and accessories. So confirms the plan. So this confirms the platform's low-cost, scalable nature for small robotic research and education. So now we can move to the conclusions part. So here, design and implemented a low-cost modular sound robotic platform. We developed custom PCBs and a 3D simulation environment in Playasine. We fabricated 3 robots and validated our system. So in here, 54 per unit for our robot system in our platform, and demonstrated affordability, scalability, and effective sound coordination. And in future, we now working on to improve the number of robots in our swarm, 5 to 10. Okay, to create that, and now we are working to integrate advanced swarm algorithms in our platform. Okay, so these are the reference what we used in our present here in our presentation. Okay, thank you all of you. Now it's time to ask questions.
Hi, Tisara, can you hear me?
Yes, now I can hear you.
I think we have questions. So what's the communication protocol you use for the swarm robot? So how they communicate with each other? So when you have the
In this phase we have a leader in our platform. So through ESP32 microcontroller, there is a leader. So the communication is through the leader through Arduino platform.
So what's the maximum number of robots do you support in this in your setting? I think in both in the simulation or in your real PCB design.
Actually, in here, actually this is a continuation project, and this is the actually first phase. So in the first phase, we validated using 3 robots, and actually now we completed the second phase also. In there are 5 robots. So actually no limits for the robot number of the robot in physically and simulation platform. No limits for the number.
So with the increase of the robots number, will it affect your robotics?
Here, when we are increasing the number of robots, we are planning to divide the whole swarm into subsections and make a leader for the subsections. Then we are making to communicate through those leaders. So those leaders will selected randomly. So we are targeting to communicate through that leaders.
Yeah, thank you for clarifying.
Thank you.
Thank you. Do anyone have any other questions? If not, we can move on to the second talk. Okay. So the next one is about the reinforcement learning-based activity recommendation for providing emotional support. And let's welcome the next speaker, Yosoda, on this presentation. Thank you.
Thank you for giving me the chance.
A very good morning to all of you. The title of our research is Reinforcement Learning Enabled Recommendation System for Emotional Support, and this is my research team. First of all, I'd start with the motivation and initiative for the research. So according to the statistics of world health leaders, such as WHO, 61% of the adults and 73% of young adults report that they sometimes or always feel lonely. Loneliness is linked to depression, anxiety, and many other health problems. So if you look at computational solutions to mitigate these issues, such as support groups and mental health apps, one of the major problems that we see is that they lack item interactions and forecasting new items to the users based on their ratings or interactions. The traditional methods of recommendation systems are mainly the collaborative filtering and content-based filtering to provide different item suggestions to the users. In content-based filtering, the items or suggestion similarity is identified based on its features, and user profiles are created based on a person's past interactions. Then the user profiles are matched with the identified features. In collaborative filtering, based on certain similarity measures, such as Pearson correlation, similar users or items are identified and suggestions are provided based on those similarities. So there are traditional recommendation systems which are cross-domain and are providing suggestions for more than one medium, such as music, movies, and books. The limitations of these systems are that they often have a cold start in recommendations, meaning that they suffer from the lack of historical data for new users or new items. Another issue is that these systems often overlook the complex emotional and social dimensions specific to a user, and most of these systems do not consider the dynamic nature of preferences and emotions. So before moving on to the specific objectives of the research, let's discuss a little bit about the three theoretical frameworks that were used in this study. First of all, let's look at the concept of egocentric networks. So social networks can be divided into two main groups, egocentric networks and social-centric networks. Social-centric networks consider an entire network to come up with observations or predictions. The egocentric networks, on the other hand, focuses on an individual. Actually, we call that as egos, a network and interactions with their connected people who we can call as authors. So the advantage of ego networks is its ability to provide localized analysis for a given individual based on their connection with other people around them. So there are many use cases of egocentric networks, such as identifying users with similar preferences, recommending items such as which are popular among an ego's friend groups, so on. Then the concept of reinforcement learning that we use, well, it's a machine learning concept, focusing on learning to take actions in an environment to maximize its reward. And a reinforcement learning algorithm learns by interacting with its environment, receiving rewards for beneficial actions and penalties for detrimental actions. Over time, the algorithm maps environmental states to actions that maximize the expected rewards. So coming back to the question of what is our objective for this study, we want to suggest solutions to the issues identified in the traditional recommendation systems by experimenting with the concepts of egocentric networks and reinforcement learning. We are suggesting a cross-domain recommendation system focusing on movies, music, and book recommendations. And we consider mainly actually four types of emotions: happy, sad, stressed, and relaxed. Along with personalized recommendations provided through the reinforcement learning algorithms, we consider the social context integration by using a person's social network to the egocentric network that is created specific to that person. As an enhancement, we also look at the temporal dynamics of user preferences and emotions, and we try to incorporate those dynamics as well on the suggested models. Let us now look at our suggested system. So in suggested approach that you might see a diagram on the screen, egocentric networks are used within the reinforcement learning model to focus on giving users the most relevant suggestions right away. First, the system builds an egocentric network for each user based on the media genres linked to their self-reported emotional states, which are selected during registration. We'll learn what registration means, and uses this information to create a personalized preference profile. Using this, the model selects the best machine recommendations stored in a database, which is then shown to the user. Then the user can provide feedback on the suggestions provided by the system, and that feedback will be looped back into the reinforcement learning algorithm, and it will be contributing to the next set of suggestions. So here we utilized a combination of data sets, Movie Lens for movie preferences, Goodreads for book recommendations, and Spotify list to simulate realistic multi-domain user environments. So if we dig deeper into the initial phase of this approach, which we call as the registration phase, here the system builds an egocentric network for each user based on the media genres according to their preferences, linked to the 4 types of emotions that I mentioned earlier. And using these initial inputs, an egocentric network is created for a particular user. And the next question we have is how the connections, or let's say the edges, are created in the egocentric network. We have experimented with a few types of similarity scores generated on the user's initial genre preferences matched with emotional states. And if the similarity score between 2 users is greater than a threshold value, here in this specific case, we have used our threshold value as 80. Then an edge is created between those 2 users, meaning that they are connected. Otherwise, if it is below than the threshold value, we assume that there is no big link between the users. In the reinforcement learning model, there are 2 aspects we are looking at: exploration and exploitation. In the exploration stage, you would see it on the left-hand side. The suggestions provided through the user's own preferences and ego network. The system shows a few random or different suggestions to explore new interest for the user. If the user interacts with these new preferences, those are updated dynamically in the system's database. If you go to the right-hand side, the exploitation stage, if there is an egocentric network created on the user, then the media items are recommended by analyzing the egocentric network and its features. If there are no ego results coming for a particular user, then the suggestions are made based on the initial preferences that I have mentioned in the registration phase. And the suggestions would be further improved through the learning process that is happening in the reinforcement learning algorithm. Now let's look at an example of exploitation when there is an ego network created on the user and there are ego results. Suppose there is a particular user, let's call that person as user 1. The system has identified that movie 1 has taken them to a better mental state. So this particular movie is stored as an immediate suggestion to user 1. If there is another user, let's call that person as user 2. In the same ego network, meaning that they have similarity in their preferences, and the similarity is greater than the threshold value. Now, movie 1 is recommended to user 2 as well. Then based on the feedback of user 2 for movie 1, the system might update its relevance by adjusting the ratios in the database. And along with the process, the exploration that we discussed earlier still happens, meaning that the model would still get suggestions for unexplored media items and keep track of users' feedback on those suggestions. As an enhancement, we have also looked at the temporal nature of user preferences. We acknowledge that user preferences might change from time to time. Therefore, at the exploration stage, the reinforcement learning algorithm would provide new suggestions to the users and dynamically change the activity ratio based on this simple formula that you see on the screen. And initial preference values would be changed according to user feedback on these new suggestions. For example, after watching a particular movie, a user might give a thumbs up, which is a positive reward for the reinforcement learning model, and it will be matched to a predefined reward value. And based on that the preference value on the database would be updated. If it is a negative reward, like a thumbs down, then according to the formula, the ratio will be reduced, and again, the database values would be updated. So these are the experiments that we have carried out. First, to decide the similarity measure when we create in the ego network, we have tested with 2 approaches, cosine similarity and fuzzy meshing methods. Out of these, fuzzy meshing shows the best outcomes, and we have used a threshold value of 80 when creating the ego network. For the reinforcement learning model, we have experimented with 3 widely used algorithms: Bandit model, active learning model, and the active critic model. You can see how each of these models compare with simplicity, their popularity, adaptability, compared with each other. And all these 3 models have exploration and exploitation trade-off implemented. And we need a method to adjust the recommendation scores, and we have experimented with two approaches, sample average and weighted average methods. Out of these, so if you see the red color graph, it has power performance, meaning that the weighted average method showed better performance, and we used it to update the ratios considering both past and recent actions. Here you see the performances of the three reinforcement learning models, bandit model, Q learning, and vector-treated model, respectively. When compared the three, the multi-arm bandit model showed the best performance with the highest accumulated reward distribution over a given number of episodes. So one of the major objectives we wanted to experiment with throughout our study was to incorporate ego networks along with reinforcement learning to capture the context of users, whether there are connections between different users, along with personalization. Therefore, we conducted an experiment to understand whether there is an adequate contribution from the ego network to the accumulated rewards, which the system will use in suggesting items to the user. The graph you see on the screen will show that the accumulated reward with the egocentric network shows significant performance improvement compared with that of not having the contribution of an ego network. Which actually takes us to the conclusion that the integration of reinforcement learning and egocentric networks showcases better performance in activity recommendation systems with the ability to adapt and evolve based on user feedback, which is coming from reinforcement learning, and personalization and making recommendations better, which is coming from the egocentric network. So this study is currently at its first phase. We have plans of incorporating automatic and real-time emotion recognition algorithms using methods such as face recognition to create a system with better usability. Some other improvements are in-app recommendations to improve reward functions. And of course, we can work more on the evaluation phase. We were able to conduct only a limited number of experiments due to time and resource limitations. Therefore, more experimentation and evaluations is a high priority for the next phase of the research. That concludes my presentation. I would like to thank the research team, Nimnath, Ms. Safuni, and Dr. Darshana for their dedication and commitment. Thank you.
Yes, thanks, Yasoda, for your canned talk. And do anyone in the audience want to ask some questions for her talk?
There were three data sets that were used specifically for movies, books, and songs. For the movies, we used MovieLens. This is a particular data set. Goodreads for book recommendations, and Spotify song for song recommendations.
So you had the same, for the same user, you have all the three different data set?
Yes.
It's publicly available somewhere? So when you are like measuring this distance, so you go with the, what is the, you measure the distance between two users in one location. So how the user profile look like when you are measuring the distance?
So what we want to do when creating the ego network is we are checking the similarity of preferences. So for an example, if I say that when I'm sad, I would like to read romance novels, something like that. If another person would say the same thing, then we assume that they have a...
Usually text.
Yes.
You are measuring text.
Yes.
Why don't you try like embedding techniques to, because you get a much more meaning with the text, because like those distance matrices are all way of measuring the distance.
Exactly.
To use like embedding technique, word embedding kind of thing, maybe you may get distance better performance.
Yes.
Thank you.
That is being used in reinforcement learning, and yes, we can try out next phase.
So if no other questions, we can move on to the next talk.
Thank you.
Thank you very much. And the next one is about the investigation of quantum key distribution protocols under Trojan horse side channel attack. And let's welcome Kibuba Karen. Thank you.
Very good morning, everyone who are present here. And myself, Kripagaran from Ernet India, and uh, my analysis is all about investigation of quantum key distribution protocols under Trojan horse side channel attack. So we all know that one of the secure ways to generate keys nowadays is by quantum key distribution, right? So because it is safe and secure, so we are moving on to generating keys by QKD. And thing is like, though we generate keys from QKD, it is quite vulnerable to attacks. So say, for example, we can call it as a DOS, denial of service attack. Even Trojan horse comes under DOS, DDoS attack. Then if we say another like photon number splitting attack and so on. So this study is all deals with about several protocols such as BB84, E91, SARS-04 protocols. How Trojan horse attack affects these protocols. When we try to model these things, and we try to analyze the impact of this attack, like Trojan horse attack over these protocols. So we primarily used IBM Qiskit for modeling these things, and especially IBM Terra and Air for modeling quantum circuits and for noise modeling. Results anyway shows about which one is tolerant to attack and so on. I will come to that particular point when I show the results topic. And this is about general cryptographic concepts that we have QKD, Alice, Bob, and key has been generated. Means key used to generate by using this QKD nodes. And this classical channel is not classical, meaning that is for post-processing work, and key has been generated by using that, and key will be fetched by using encryptor and decryptor, and these two applications will be using it. So it's a general cryptographic concept that I just told you with QKD system. And these are all some related works that they have worked on some primary protocols such as BB84, BBM92, SOT04, E91, and so on. And there are some protocols that is based on prepare and measure, entanglement based, and all those things. So here they have used if you see the references from 1345 and those references they have talked about, meaning they have analyzed about limited side channel and hardware attack analysis, and some references have modeled threat modeling, and there is no such practical attack scenarios they have considered. And there are some papers that they have they didn't consider about the Trojan horse attacks. And so in this analysis that we have bridged the gap by modeling Trojan horse attack to bridge the gap in the literatures. And this is about methodology that I just wanted to show you what is BB84. And say, for example, here in this diagram, I just want to understand one thing, that our analysis, meaning the protocol, is all about usually the single photon will be transmitted from QKD Alice to Bob. So there are some protocols present to transmit such single photons. So based on that protocol, how the key has been shared. So that's very important actually. So in that context, there are some protocols based on prepare and measure, entanglement based protocols. So here, when we come to this one, so this is first one is about I'll just touch upon what is BB84, SARS protocol, and E91 so that it gives some better clarity. So this is about BB84 protocol, and we have rectilinear and diagonal basis. And rectilinear basis, it has it represents 0, 90 degree by means of this polarization, and by means of 0 degree and 90 degree. Whereas in diagonal basis, if we take, it has again 45 degree and 135 degree polarization. So 1 can be represented in 2 ways and 0 can be represented in 2 ways. And so that 0 and 1 can be represented in 4 combinations, right? So this is about representing about BB84, how if we transmit 0 and 1s between Alice and Bob, then how it's being transmitted. So because of these 4, polarizations, like we have angles such as 0, 45, 90, and 135. And there are some bases also. Combining these bits and bases, it forms several combinations, right? And in the same way, SARS protocol also works based on here. If you see, these are all possible states that can be transmitted. If I want to transmit, there are 4 bits, means 4 combinations that if I want to transmit. If I want to transmit 0 with these 2 bases, and if I want to transmit 1 with these 2 bases, so that it's not 0 and 1, it can have more states to transmit it. Whereas in case of E91, it is entanglement based protocol, meaning that 2 or more bits can be uh, combined together, so that at last when we transmit it, 1 bit will be dependent on other bits. So it means 1 bit will be dependent on other bit. So when there is some disturbance by E or something like that, so it is easily detectable. And those things that I will come to this result part. And all these protocols, right? So we saw these protocols, and this has been modeled by using IBM Qiskit by means of gates such as X, H, adamant gate, and X gate, C0 gate, and all those things. So we have modeled all this, and also we have considered bit flip noise by using by modeling that bit flip noise by using C0 gate. It's a kind of a quantum computing concepts too, but because IBM Qiskit generally we use it for quantum computing, and we use those concepts to model these protocols. And when we have evaluated these parameters like quantum bit error rate and secure key rate, how much error happens when E, like E in the sense here we consider the attacks such as Trojan horse attack. What is Trojan horse attack? That I will come to it here. So when we transmit bit, meaning single photon bits from Alice to Bob, we have in between, say, for example, coupler. It means this is the schematic diagram that we followed this one to model it actually. So this can be of any of the ways. I'll tell you this one. And when we transmit bits from Alice to Bob, so here there is some injection of photons into it in order to get the idea, or in order to get the knowledge, or in order to get the track the bits, what it has been transmitted. So in practical scenarios, actually in ERNET, we are doing with the hardware systems, where there what happens is like sometime when we deploy it in practical applications. So usually when we go for isolation, right? So there are several fibers in the several fibers laid in the ground and so on. During improper isolation, there are some nearby fiber, even the nearby fiber impacts the other one because of improper isolation. So these kind of things also comes under concept of a Trojan horse, because some other fiber source is disturbing other one, right? So meaning that the one that we want to transmit by using the fiber that we want to transmit. So here we have used continuous wave laser, meaning we are injecting more photons into it. We can vary the photons, say for example 10%, 10 to 90%, and 20 to 80, something like that. We can vary from 10 to 90% of side channel attack, meaning we can inject more number of photons into it and we can analyze those things. So this is the methodology that we followed. Like initially we initialize the parameters. This is all I have done by using IBM Qiskit framework, and then protocol execution loop that runs the iteration for n iterations. And we establish the states for each protocol. What are the states need to be transferred, and what are the primary bits that need to be transferred. Then we designed noise, meaning we model the noise, that is a bit flip noise here. And then after that, we go on selection of random measurement basis, and then we compare the bases between Alice and Bob, and we find out the parameters such as Kuber and secure key rate, that is SKR, we say. And coming to the results, and when Eve has knowledge of transmitter bits, that is when Eve has 10% of knowledge on the transmitter bits, so it causes more disturbance, meaning that if we see the very first graph, if you see when it has 10% of transmitter bits, it creates more disturbance. And when it has 90% of knowledge of transmitter bits, then it creates less disturbance. So that is the inference we get over all the protocols, but the Cuber percentage is varying between the protocols. That comparison we could see we could see in the very next slide. So if we see that, say for example, if Eve has knowledge of a 10% of transmitter bits and it tries to inject some photons and it get back some reflection over it. So meaning that when it has proper knowledge, so it Eve doesn't disturb the current setup what it has. So whereas when it has the knowledge of 10%, it creates the disturbance more because it doesn't have the knowledge on the transmitter bits. So that's the inference that we could get over all the three protocols here. Whereas if we see the comparison, right? So comparison over all three protocols, meaning so which one is more tolerant, meaning that we run it like when Eve has knowledge of a 10%. So obviously the Cuber goes high because it doesn't have a knowledge on transmitter bits, so it creates more disturbances. But SARS-04 and E91, these two protocols are prepare and measure protocols. So this one is somewhat tolerant, and whereas other one like E91 is the one that suffers a lot here because it is entanglement based. Because we know that one bit is dependent on other bits, meaning there are two bits can be combined together, or two or more bits can be combined together. When one bit is disturbed, obviously other bits also will get disturbed because of these concepts. So E91 suffers a lot. So in the same way, how the secure key rate gets affected. When the Cuber rate goes high, obviously key rate also comes down because when error rate is high, when error rate is high, so obviously key rate will go down. So when it has a proper knowledge, then key rate is high. Whereas in this one also E91 suffers a lot because of more Cuber, and it generates less key over other protocols here. And this is just a short comparison. Because of a prepare and measure and entanglement base, E91 follows entanglement based approach. So because of that, it suffers, it gets more Cuber and less key rate. And by concluding this one, and this can be in the future, it can be explored QKD performance under other attack scenarios, and it can be developed and test countermeasures, how it can be mitigate these things but in general, in the hardware analysis that we are doing, how it can be mitigated, and those implementations are going on. And this is about the investigation of QKD here over other protocols. Thank you.
Thank you so much for the talk. And any questions from the audience? Yeah, if not, since we are running out of time, maybe we can move on to the next talk. Thank you so much for the presentation again. And the next presentation is dynamic workflow scheduling for cloud computing, strategies for optimizing response time and energy consumption. And let's welcome the next speaker, Harath. This is a online presentations.
It's the 6th Asia Pacific Advanced Network meeting. And Today I will be presented on my research title on dynamic workforce scheduling for cloud computing, strategies for optimizing response time and energy consumption. Ms. HMCC Herat and Mrs. Ekin Jaisena are the authors. And this is the part 1. It is described on the introduction of my research. When we discuss about my research, we should have a clear idea of what is the cloud computing. Cloud computing is the on-demand delivery computing services, including servers, storage, databases, networking, software, and analytics, other than storing files on our hard devices. We can access those services via the internet. This figure describes basic concept of cloud computing, and end users can access these cloud computing services via the internet. And then we should have a clear idea of what is the workflow in cloud computing. It is the sequence of interdependent computational tasks, and it has the specific order. And there are two main types. Those are the static and dynamic. In the static workflow, it cannot be changed according to real-time changes, and dynamic scheduling can adapt to the real-time changes. And according to this figure, the users send their task as the request as the workforce, and these tasks and workforce scheduler has the critical responsibility to assign the specific virtual machines. And then why we motivate to this research, because of these three elements, why we motivate to do this research. Those are the limited focus on the dynamic workforce scheduling, and limited focus on the multi-objective workforce scheduling, and the recently not focus on the response time and energy consumption parameters in workforce schedulers. And this is the second part of my presentation. It will be described in a literature review. According to literature review, I collect the details based on three main categories. Those are the cloud resource management, workforce scheduling, and dynamic workforce scheduling. Based on these research, I can identify those existing research limited focus on the multi-objectives, mainly those research focus on the one or two metrics, and also limited focus on the dynamic workforce scheduling. And this is the third part of my presentation. It will be described on the research problem and objectives. When we move on to the research problem, it is the how to enhance the dynamic workforce scheduling algorithm that optimize response time and energy consumption in cloud computing environments. And also there are three main objectives based on this primary objective. The primary objective is to reduce the response time and enhance energy efficiency in dynamic workforce scheduling in cloud computing. And it divides into three parts. Those are to analyze the impact of dynamic workforce scheduling on cloud performance. And second one is to develop a workforce scheduling algorithm based on the vertical span optimization. And the last one is to evaluate the effectiveness of proposed this algorithm. And the fourth one will be described on the followed methodology in this research. And this enhanced and proposed algorithm workforce scheduler I named as the adaptive multi-objective workforce scheduler, and it followed the three main phases. In the initial phases, define the task details like size, resource requirements and available resources like number of virtual machines, number of CPUs, and memory limitations. And optimizing phase, we evaluate the response time and we calculate the response time and energy consumption, and also we calculate the fitness function, and also when prioritized based on the these considering other elements. Then when we move on to the evaluation part, we evaluate these result based on the existing result and we introduce the new enhanced algorithm. And when we move on to the simulation parameters, those are the simulation parameters, and we use the cloud sim environment to this research to do this research. And the fifth part of my presentation will be describe the result of my research. To evaluate my research result, we use the existing tool to research details and those results. We mainly collect the response time versus number of virtual machines in the different number of virtual machines. Those are the collected collected details. Based on these collected details, we can prepare this diagram, and our purposed algorithm show like this. And also we collect the details based on the energy consumption versus number of virtual machines. And also we can get the result like this. And also we collect the data, completion time, and waiting time also. And those are the results. Based on these results, we can get the final results like this. And according to existing result, comparing, we can get the reduced values in these two parameters. And in the sixth part of my presentation, describe the future works based on my research. Mainly in this research, we focus on the response time and energy consumption. For the future works, we will hope to integrate the additional parameters like cost and security. And also in these enhanced algorithm, we mainly use the particle swamp optimization. Otherwise, in the future works, we also evaluate the ant colony optimization too. And also, last part of my presentation include the references that are used to create this presentation. Those are the references. And thank you very much for listening and the contribution.
Time and energy consumption drop. And any questions from the audience is very welcome.
Okay, thank you for sharing. Actually, I have a question. Do you have a primary for any task? So any task has the same response level? Oh, yeah, like this. So is the schedule? Oh, I think. So it mute, is our microphone mute? So we need to unmute. Maybe we can check with the speaker. Hi,
Hello.
Paris, are you here?
Am I audible?
Oh, you're here. So maybe I change the question, so most straightforward. So, is your scheduling model task-based or workflow-based, or is a hybrid one?
This is the hybrid one because we're considering the two parameters, and based on the weighted parameters, we collect the data in different parameters and weighted.
Yeah. Actually, how do you trade off the response time and the energy, save the energy consumption? Yeah, I think both improved in these two metrics.
In previous researchers mainly focused on one parameters. Those calculation I get to these research, and now my research I give the weighted for the based on their requirements, user requirements. Then give the weighted for some energy consumption and response time. We can allocate their places to the cloud environment based on the mainly focus the weighted.
Okay, thank you.
Any other questions from the audience? Okay, if not, then thank you, Harris, and for your talk. And we are going to the session 2. So session 2 is about AI and machine learning. And the first presentation is about the rise of AI in Asia, examining relationships between artificial intelligence adoption and social capacity building. And let's welcome the speaker online, the Visia Serha.
Good morning, everyone. I am Vidyasagar Vimeshwaran from the Sri Lanka Institute of Information Technology, and I am honored to present our research at International Conference on Asia Pacific Advanced Network 2025. Our study, titled The Rise of AI in Asia, examining relationship between AI adoption and social capacity buildings, was conducted in collaboration with researchers from SLIT Malawi, SLIT Northern Uni, and University of Pennsylvania. Researchers from SLIT Malawi, SLIT Northern Uni, and University of Pennsylvania.
We can invite the professor to just present his presentation using Zoom rather than playing the video. Yeah, your video cannot be played properly. Let's make the presentation.
So first talk about that analysis of this content. So first we talk about the introductions and aim of object and why this study is important and how its major areas of this research.
Could you please share the screen? Share the presentation slides.
Oh, you already shared. You share.
Okay. Let me know.
We don't need the small window. Yeah.
Yeah, It's not in the share screen, it's a video. Yeah, maybe the presenter, could you please help share your screen from the Zoom from your side? Do you need more time to prepare?
I will manage most. Okay, so can you see my screen?
Not yet.
No? Now it's okay, right? I am audible, right?
Okay, so this is his screen. Okay, thank you. Yeah, we can see
Yeah.
your screen.
Yeah, okay. So today our topic is the rise of AI in Asia, how to examining relating between AI capacity, AI adaptation and social capacity in building. So next move to that our content like introduction and aim of objects and why we need this subject likewise and major areas of this research and everything and our contributions and how do we contribute and collaborate this kind of research studies and methodology, how what are the methods we applied here and results and discussion and conclusion and future works. So now let's move to the introduction. So in now Asia we consider so initially in the Europe countries or in the US countries, they are more interacted with AI. But nowadays it's AI is more trend and more capacity in the Asia Pacific. So nowadays our Asian regions use the AI very popularly. So this is not a trend. This is the culture and it is a big technology now adapted in the Asian Pacific. So now we have that case studies in a several ways. So now we have some statistics points. So in India, 20.2 global AI activities in hand, and in Singapore, 28% developer growth. It depends on AI, and China, UI, Hong Kong, and Sri Lanka as well. So in after last 1 year in Sri Lanka, it's 18. The percentage of the AI usage is the 18%. So now we move to that platform and we have some case studies to related to the things and we get in the feature. So now the adoption of the documentation like quantity or quality. So we have to the two measurements. We can get the Google Forms or everything circulate with the others and get some data. So like the quantity and quality also, we can take the documents and some video interviews and everything. We collected some data. Then we analyze the everything, and after that we come to the one framework. So how to the AI in the Asian region, how to socially interact with the Asian peoples. Likewise, we come to the one conclusion and we propose a framework. So how to understand nowadays AI, how to familiar with that peoples in Asian peoples. Likewise. So now the big thing is now in India, 24.2% global AI activity will happen. In Singapore, we analyzed the GitHub repository, and according to the GitHub repository, 20.8% developer growth is up to 20%. It's increased to 28%. Then after that, then we have the efficient and workforce capacity also happen. So like this, we have to have, and we have to have the several country as China. In China also, they are now moved to the next level to the AI, and as Hong Kong and Sri Lanka as well. So up to now, so we have some patterns like in the previous time we have the AI adoption pattern. We have some integration across sectors like healthcare and education and public service, and analyzing the trends. And now in the government and digital infrastructure, everything related to the AI. So now in the socially in the any institutes or any organization, they are include the AI parts in their work. So it's increased their work very efficiently and moving forward to the next level. So this is our literature review, like how they are working like that. So if it trade-offs or frameworks, everything, how to it's impact the social capacity impact. So effect of workforce and development and institutional efficient inclusivity. So accessing the trade-offs as well. So social cohesion and cultural adaptation. So how it's distributed in the social people, how the normal people use the AI, how the normal people use the ChatGPT. Likewise, so if you have give any problem, then the normal people have how to handle using of the AI tools. Likewise, we are getting that particular things. Then after that, according to your framework, we decide to having that how to interact with AI in the people's. Likewise, we made a framework. So here our contribution, how we get the data. So first we get the compressive analysis. So mapped AI adoption and patterns across the Asia healthcare, like healthcare or education or public service. We get that methods and regional insight. So we have some Google Trends data. So in the Google Trend data, we have to get some popular. So how in India, how it's AI increased, and in how to use the AI project in India. So in the software development, they are mostly using the AI, and they are build a separate AI project as well. In Singapore, the developers, 28% is developer did this. They are increased their developer capacity to that level. So using the AI. So initially it's very difficult to them to handle a big problem, but today we have the AI. Then we have a lot of in the software development. We have a lot of automation tasks. It's a repeated task. So using the AI, we can easily grow in a level. So we can easily automate the repeated task and move to the next level. In Sri Lanka, in the February, in the social capacity, they are using the Facebook mostly. But after February, the study said they are mostly use ChatGPT than Facebook. Likewise, so it's in Sri Lanka also the AI using of the AI culture is way more. It's more increased. So now in after February, now ChatGPT ratio is very big, more than Facebook. Then like that, that's why we come to that social capacity framework, and we have some policy implications and novelty as well. Then methodology. So think this is our methodology. We first collect the data in a two approach. That approach, one approach is quantitative. So we use the Google Trends up to April 2024 to 2025. In our research paper also, we are at the graphs and papers and how it's increased in a way. We organized in a subset and we distribute that one. Then GitHub activity. So how in the according to the public GitHub repository, how they are using the AI project, how they are integrate the AI things in the repository. Likewise, we get some data in quantity. Then qualitative, we do some case studies. So according to the case studies, we conduct some interviews and asking some things in that. Likewise, and we have the semi-structured interview with the expert. So we have that some industry expert. Then in the industry expert, we collaborate with them and ask some questions. How it integrate the AI, how to use the AI, how developer use AI. Likewise, we have some getting some using the interview, some getting some data and policy document. So we get some policy document from some other organization, and according to that documentation, how they are impact the AI impact their product and productivity. Like that, we get that. Then after that, we categorize every country, like in Sri Lanka, how it's affected, and India, how it's affected, like that in China. So likewise, we are get some scope. Then after according to our framework, that our framework is a TOE, we call as TOE in the cross country comparison. So how it affect to every country. So compared to other regions like Europe or US countries. So initially the Euro and US they are top in the A, but in today onward after 24 after ChatGPT or 2021, now the Asian people mostly use the AI thing. So it's very good thing because every organization they are using they are increase their productivity. So it's a very good thing, but we handle in a good manner. So that is the main thing. So according to our framework, we get that one. And then after that, data sources like survey. So according to the survey and industry report and social media discussion and online, we get that search behavior. Then after that, we have the limitation. So data ability bias and reporting violation. So we have that limitation because we have the violated data as well. So according to data, we first categorized, and according to that, we generate some graphs. So in our research where we include that graph, so you can see that one as well. So here this is our thing. So how to get the input, then how our process, and how get the output. Likewise we get that one. Then results, that in the results we all have we indicated in this graph. Then we get the survey. So I already mentioned that one. In the Singapore, they increased the ChatGPT for the 2024 it's only 40%, but now it's 80 points. So they are double. In Singapore, they are charging in the ChatGPT, it's doubled. Likewise, so in the UAE also they are 45 to 98%. And in Sri Lanka, up to February, they are mostly use the Facebook. But today, so now in this time, they are using the ChatGPT mostly. So it is a good sign to they are using the AI in their work or in their culture or in anywhere. They are using the AI. So it's kind of good thing. As a developer in India, they are using the project. So we already mentioned that GitHub account. So we are mentioned the GitHub account, and likewise we get that one. And Singapore also same. But in the China, I think they are not in the China. They are not use the GitHub. They are using the different platforms. That's why our data is not get this kind of growth. But in China also massively they are grow the AI things. And then we have that one equation called the social capacity. According to that AI divided by social capacity, we get some ratio. According to our ratio, we get some kind of things. Then this is our graph. So according to our graph, you can take the results, and in the results, it's massively show how AI impact in Asian countries. Likewise, we get that kind of graph. We make that graph according to our studies. So this is our graphs. Likewise, so in Hong Kong also, it's a 50%. Now it's 18%. So it's increased now. So likewise, it's increased. So this is China and UAE. So we have divided in several countries according to a country how a impact. Likewise, each country wise we each year each country wise we are divided as this kind of getting this graph. So the mostly they are using the AI things without they are not using the Facebook or Instagram. They are mostly use the AI things now. So it's good sign. So that's why we indicate this kind of thing here according to our case study. So this is our study in India, how a project is involving several things, and Singapore and China and Sri Lanka as well. So in Sri Lanka and Hong Kong, all small countries, but now they are moved to that A things very fastly. So they are growing in a good manner. So according to our studies. Then after that conclusion, so this is the thing we analyze now. So then then after that our next studies we are more into the Sri Lankan thing. So in the Sri Lanka we have more related data we have. According to our data, we move to the next level. We analyze each thing each month. We analyze everything and how a impact every life, everything in organization, in academic institutes, or in industry, or in social organizations. And likewise, how it's integrate that one. Likewise, we get some idea. According to our idea, we move to our study in the next level. So this is our future work. So we have more to have the new frameworks. According to creating our new framework, we move to the next level. So this is my presentation. You have any questions? Let me.
question for the relationship between the social cohesion and the AI adoptions. I'm not sure whether you have try to control some of the confounding variables, because this may not be the core cause. So there might be some other like social factors that may influence the social cohesion and also the AI adoption. So I'm not sure about their direct relationship.
So social capacity, we take according to our data in a Google Trends and GitHub according to our GitHub activities. We get some data, and according to that, we build that equation and get some conclusion according to that.
Okay, so if no other questions from the audience, we can move on to the last presentation. Thank you.
Thank you.
So the last talk is the Political Net, a transformer-driven framework for fine-grained classification of Bangla political hate speech in social media. And let's welcome this presenter, Sabrim. Thank you.
Sabri Mahmood. I am from Daffodil International University, Dhaka, Bangladesh. Today I will present our research work titled PoliticaNet, a transformer-driven framework for fine-grained classification of Bangla political hate speech in social media. This research was conducted in collaboration with Samaun Rizvi Pail and Jawad Hossein. First, we need to know what is political hate speech refers to. It refers to offensive or threatening language targeting individuals or groups based on their political belief, affiliations, and role. It includes derogatory remarks, hostility, and misinformation often aims to politicians, parties, and or social movement. This type of hate speech can be explicit or passive. It plays a major role in fueling polarizing, especially in politically sensitive regions. Why we need to detect this? In Bangladesh, political polarization has sharply increased on platforms like Facebook and YouTube. Manually moderating the volume and speed of this post is impossible. Existing detection system mainly focus on general hate speech or offensive, often use binary classification like simple hate and non-hate. That's not enough. That is a critical gap when it comes to automated fine-grained classification system for Bangla political content. Current models often fail to nurture the political hate speech. Most posts are sarcasm related, indirect attack, or code language, which are difficult to detect using simple models. That's the main issue here. That's why we proposed a system that goes beyond the binary classification, capable of detecting different type of political hate speech. Our main goal is to develop a robust transformer-based model that can categorize the Bangla political content in 4 fine-grained classes: direct hate, passive hate, non-political hate, and other. Such categorization enhance moderation tools, support research, and promotes healthy disclosures. Our contribution here is that we created a dataset with the PolyHashD. We proposed PoliticaNet, a transformer-based framework built to classify hate speech with high generosity. We proposed expensive experiment compared traditional machine learning, deep learning, transformer, showing the superiority of our approach. Now we need to talk about the related work. Previous research on hate speech detection include Malik et al. Used and transformer-based models like Banglabird Electrica for binary hate speech detection, achieving over a top F1 score across without political subtitles. Sharma et al. Worked on Hindi Bangla code switch hate speech with multi-class abusive language classification. Wang et al. Analyzed Chinese political hate using lexicon combining with BART for multi-class classification. Guilil et al. Studies Arabic YouTube political comments reaching with high F1 score and lacking fine-grained political categories. In Bangla, but Das et al. Applied attention-based RNNs on a small dataset but without political focus. Our work fills this gap by focusing on fine-grained political hate speech detection in Bangla, a low-resource language. And if we talk about the data collection process, we collected data from Facebook and YouTube during political sensitive period in 2024 in Bangladesh. Annotators are guided the created list of political figures, political leaders, political protesters, coordinators, and intermediate government advisors as named as Samanwayaks and Upadeshtas to accurately identify political reference. To minimize bias and echo chamber effectively, we emphasize balanced ideological representation by sorting text from diverse political viewpoint and manually filtering those datasets. If we need to talk deeply about the datasets statistics, here we can see that our FB polyhash dataset contains direct political hate 2776 samples and total words and unique words all are in table. Passive political hate 2233 and non-political hate speech 1592 and other or neutral or other dataset 4517. All those in combining 11k plus dataset and their unique words, total words are described in this table. Most posts are short under 2000 characters, reflect social media brevity. Political hate speech classes trends to have slightly longer posts showing their nuisance hate often require more context. Now, if we talk about the methodology, we implemented two diagrams here. We can see we designed a transformer-based framework using Banglabird Squad to classify text in 4 categories, and we create a pipeline includes text processing to handle social media noise, informal language, tokenize and encoding with this transformer model, fine-grained classification models on learned contextual embeddings. We compared all the models in machine learning, deep learning, and transformers, and here and this diagram shows all the models comparisons and the systems. Now, in terms of the result, we can show that a table was represented here, and all the machine learning, deep learning, and transformer models result F1 score, precision, recall all are tabled here, and among them the transformer overall all these models, the transformer based model Banglabird keyword obtained 77% and F1 score 0.74% actually. Here we can show that these models show strong performance in non-political speech and other category, but it overlaps in direct and passive political hate speech. That's why we analyze in those in two categories, error analysis of these in 2 categories. One is quantitative analysis, as second one is qualitative analysis. In quantitative analysis, we include a classification report and diagram which shows that which mainly shows the misclassification include 133 direct political sample misclassified as passive hate, passive direct passive political hate, 54 passive political hate samples misclassified as direct political hate, 108 samples from other class misclassified as non-political hate speech. And this is the quantitative analysis of this. And in qualitative analysis we tested some samples and which handles explicit hate speech well and struggles with subtitles, sarcasm, metaphors, implicits, and sometimes over refills our political keywords and causes false positives, misleading, ambiguous and neutral post, and indicate limitations in contextual understanding. If we are talking about the future work, we expand the data set. We want to expand the data set using Romanized code based and dialect Bangla to better real life world diversity, improve robustness by data augmentation, class imbalance handling, and sentiment awareness modeling, explore large transformer models and cross-language transformer learning to enhance the generalization. And in all the above discussions introduced, AB Polyhash D, a fine-grained Bangla political hate speech data set, a transformer-based framework achieving strong performance. All these challenges, this work proves the way for better annotated moderation and research in low resource language like Bangla. And then the next slide improves shows the references of all the papers here. And that's all from me. Thank you for your attention, and I am happy to answer any questions.
Thank you so much for the nice talk. Any questions from the audience?
I have few questions.
Hello?
One is so have you used Hugging Face available model and fine tune, or you use the model as it is?
Yes, I fine-tuned them with my data set and with improving the learning rate and dropout rate, and by using other things which need to fine-tune my model actually.
I mean, you use QLoRa or LoRa or anything specific method?
Adam job actually.
So other thing is like when you are labeling the data, so you have political hate speech, normal hate speech, and non-hate speech. Have you identified 3 classes, or you go with 2 classes?
No. Actually, I labeled the dataset in 4 classes. Actually, political hate speech in 2 categories: direct and non-direct. Then non-political hate and other. This other
Who labeled the data set?
me, my 2 teammates, my 2 co-researchers, and then we use another another expert who is not from our research to finalize this labeling is okay or not.
Yeah, okay, thank you.
Yes, I have another question for you. So I saw that in your error analysis, you use the counting for like misidentification, and maybe it would be more informative to just present the false alarm rate, the hit rate, and the discrimination sensitivity, so that we can know the ratio.
Sorry, I don't understand the question. Please repeat it again.
Yes, so in your error analysis, I saw that you used the count for the misidentifications. But since we don't know the total number, so it may be more informative to just use the hit rate, discrimination sensitivities, and the false alarm rate.
Oh, actually, we do not count that actually. We just find out the accuracy rate and for our test case. And from accuracy, we can see that the errors are informal, 77% accuracy. So if you minus from 100, the error from the dataset will be 23% actually. We do not add that on here.
Oh, yeah, okay, so it's a recommendation, yeah.
Yes, thank you.
So any other questions from the audience? So if no, we can close the morning session.
Yes,
Yes,
thank
okay,
you very
thank
much. Yeah, this marks the end of morning sessions, and we have covered AI and networking tracks. And in the evening, we have a computer vision tracks. There will be 6 more presentations, and yeah, I invite you all to be there. And the presenters, thank you very much. And your articles will be published in Spring Nature Journal in the coming days. And also, they will get us a digital certificate. And also, thank you very much, our session chairs, Professor Sang and Dr. C. And as a small gesture, you will also get certificates online. Thank you very much. And then our fellows, they are helping me to set up these projectors and everything. Mr. Mustafa, Mr. Imam, Miss Celine, and Mr. Seiko. So thank you very much for your support as well. And yeah, then again, let's meet in the evening. Thank you very much.